would like to give you another presentation of calculations and actually another view of what you should actually how you can fit all these equations in the brain, and maybe this will be helpful. Let's imagine that our body, it is a glass. It is a glass with a certain amount of fluid. We have input, output, volume, and concentration of this in this fluid. And as we have drops falling from this glass, and the glass will represent actually our body, these falling drops will represent clearance, right? Clearance. And we have input from the pipe, let's say. And this input represents those, right? Those. Inside, we have volume. And actually, this volume, it is a volume of distribution. And we have steady state concentration inside. And steady state concentration, it is amount over volume. What about dosing? Dose can be either discrete or dose can be continuous. In case of discrete doses, we are using, let's say, milligrams per interval of time. And we can say that we may use a tablet 1 times daily, 2 times daily, 3 times daily, 4 times daily. And here we're operating with tau, right, with dosing interval. So if we are taking 1 times daily medication, what is the dosing interval? The dosing interval is 24 hours, because dosing interval always for discrete doses, it might be in hours. 2 times daily, dosing interval is 12 hours, 3 times daily, 8 hours, and 4 times daily, 6 hours. So here we have maintenance dose. You have this milligrams, maintenance dose over tau, over dosing interval. For continuous infusion, we have K0, and this K0, it is a rate of infusion, milligrams per minute, let's say. After that, volume of distribution. This amount of volume of distribution will be loading dose to load volume of distribution. And the volume of distribution can be calculated as a dose over plasma concentration. Steady state concentration. It is amount over volume. What is the amount? Amount, it is a dose that common. So steady state concentration can be calculated either K0 over clearance, or steady state concentration can be calculated as a maintenance dose over tau and over clearance. And this equation can be modified a little bit, and will be like maintenance dose divided on tau and multiplied on the clearance. So clearance can be calculated, once again, either from steady state concentration or from the half-life, which is 0.7 multiplied on volume of distribution and over clearance.